1. Okay, so year 10, moving on with our measurement section, and to surface area of pyramids and cones. We had a look yesterday or previous section on prisms and cylinders, where we had two congruent ends. That's what defines a prism, where you've got a 3D shape where the ends are the same shape, they're exactly the same. Pyramids and cones, cones are pyramids, just with a circular base, are not are differently shaped, and I suppose best described by having a pointy end. So if we just have a look at my my feeble attempt to draw a pyramid, please don't laugh. This is going to be an attempt at a square-based pyramid. These are supposedly straight lines. So what we end up with is something like so, where we've got a base of whatever shape. Now, in this case, I've drawn a square or a rectangular based pyramid, but that base could be triangular, it could be pentagonal, and the pyramid is defined by the shape of its base. So this one would be a square-based pyramid if I'm going to say that these sides are all the same length. This is a, let's go and do that, a square-based pyramid. Okay, and in order to find its surface area, which is our task in this lesson, we would need to have a look at the area of all faces of the pyramid. And if we have a look at it, we've got a square base here, and then we've got a series of triangles. We've got 4, 1 on each side of the base. So we've got 5 faces in total, and we would need to sum those up to find the total surface area. Now, depending on how many sides our base has, that'll determine how many triangular sides we've got leading up to the point. If it was a triangular based pyramid, there would be 3. If it was pentagonal meaning 5 sides. If it was a pentagonal based pyramid, there'd be 5 triangles around the outside of it, leading up to the point at the top. So if we have just a look at the net, which is sometimes quite a useful thing to do, we have a look at the net of, say, if I broke this pyramid down into the net, what's called the net of it's a 2-dimensional drawing of a 3-dimensional figure, and it would look something like this, where if we fold in all those 4 triangles, then we end up with our 3-dimensional square-based pyramid. Now, if I went a step further and said that this was 4 centimeters, then that would mean that was 4 centimeters. Now, what else do we need? Well, to find the area of this triangle, these triangular faces, which are all going to be the same area, I'm going to need the height. I've got the base, that's 4. I got that, but I'm going to need the height, and that's what we'll normally be given in the questions. We'll be given a length here that represents the perpendicular height of the triangular face, and let's say that's 8 centimeters there. Then we would be able to say, well, this is 8 centimeters, this is 4. So my areas would be 4 by 4 for the square, which is 16 centimeters squared. And for each of the triangular faces, of which there are 4, my area is a half times base times height, which is equal to 16 centimeters squared also. We times that by 4, 1, 2, 3, 4, to get 64 centimeters squared. We add to the 16, so our total surface area will equal 80 centimeters squared in this case. Alright, so that's how to go about finding the surface area of a pyramid. I've put on your one of your hot maths tasks is to have a look at what's called a widget, and that is a little dynamic dynamic display of how to find the surface area of a three-dimensional prism or pyramid. Please watch that, because that does things like what I've been trying to do here, but much more skillfully, in that they are breaking down three-dimensional shapes into their nets and explaining how it is we find the surface area of these three-dimensional objects. So anyway, that's my attempt there. But if you refer to Hot Maths for some more visual help and instruction on that, Hotmails. Refer to Hot Maths. I'll get it right in a second. For more demonstrations. For more demonstrations of nets from solids. Now, this is a net here. Let's just make a note of that. That is a net of the square based pyramid. Okay, what else do we want to look at? Let's have a look at cones. So draw a cone here. A bit like so. Now with a cone, we're going to need two things. We're going to need the radius. We're also going to need this thing here, which is, I'm going to call S, which is a slant height. So S equals slant height, not perpendicular height. Not this height down here, that's perpendicular height. S is the slant height, and R equals radius. Now the surface area of our cone is equal to, well, the base of the cone is pi r squared. It's a circle. And now this curved surface here around the cone, around the party hat, if you sliced it, and this is where there's a great demonstration of this on Hot Maths, so please go and look at it, where this is sliced up and it's laid flat, and what you see is a sector of a circle. And so to find the area of that sector of a circle, there's a little bit of maths involved in that, but it comes down to pi rs as being the curved surface area. There's only two surfaces on a cone, the base and then this curved area here. So the pi r squared is the base, that's the circular bit, and the bit around the cone that wraps around is the sector of a circle. Yowie, that looks terrible. I can do a better sector than that. Okay, so that's the pi rs bit, and this is the pi r square bit. If you think about joining that corner to that corner there, you end up with a cone. So that's the surface area of a cone. The surface area of a pyramid is just the sum of the base plus the rectangular sides that make up the pyramid. I'd like now for you to do the work requirements from exercise 6E, and that will be your task for Tuesday's lesson, and I will hopefully see that done when I see you next on Wednesday. Okay, many thanks. See you later.